In this video, I'm going to teach you everything you need to know to get GED math probability questions right. We're going to look at a bunch of examples that are going to be similar to things that you'll get on the real test so that you can maximize your score and move on to bigger and better things in life. So let's get started. So let's start by talking about the simple probability. Simple probability just tells you how likely or unlikely something is to happen. Now, simple probability is also sometimes called theoretical probability. So if you see a question or you see in your textbook that it says theoretical probability, note that that's just another way of saying simple probability. Now, also, I want you to be aware that sometimes simple probability is just called probability. So if on your test you get a question that asks you to calculate the probability, just note that they're probably talking about simple probability. So simple probability is expressed as a number between 0 to 1. But what does that mean? Well, in other words, the simple probability can be either a 0 or a 1, or it can be anything in between. So for example, I've never gone surfing before in my entire life. What if I were to ask you, what's the probability of me becoming a world champion surfer by next year? Well, that's impossible, right? There's no way someone who's never surfed before can become a world champion by next year. So if something is impossible, we say that the probability that it will happen is 0. Now, on the other hand, suppose it's 4 o'clock p.m. right now, because right now as I record this, it is about 4 p.m. What's the probability that in 1 hour it's going to be 5 o'clock p.m.? Well, unless we're living in a twilight zone or something like that, it's definitely going to be 5 o'clock in an hour. So if something is definitely going to happen, we say that the probability is 1. And most probabilities are going to fall somewhere in between 0 and 1. Okay, pop quiz time. If something is impossible, the probability that it will happen is what? Remember, if something is impossible, the probability that it will happen is 0. All right, you're up again. If something is definitely going to happen, the probability of that event is what? If something is definitely going to happen, remember that the probability is 1. So now let's switch gears and let's talk about how do we actually calculate probability. Well, the formula is probability equals the number of favorable outcomes divided by the number of possible outcomes. Now, I want you to note here that I checked the GED testing service formula sheet before I made this video, and I didn't see this formula on the sheet, so please note that you might not have this formula given to you on your test. And of course, if anyone has experience with this, like you've taken the math section before, you've done the GED before, please let me know down below what your experience with this is, but I just want you to be aware that this is a good formula to write down and memorize because you might not have it given to you on your test. That being said, let's talk about what I mean by favorable outcomes and possible outcomes. A favorable outcome is the event that we're concerned with, and possible outcomes are just all possible events that can happen. And this is going to make a lot more sense as we look at an example here. So let's say that I put a penny, a nickel, a quarter, and a dime in a jar. Well, what would be the probability that I'll randomly draw out a penny from that jar? So what you can do is you can pause the video, you can think about this. Here's the formula up top here for simple probability. And I want you to think about what's the simple probability of drawing a penny from this jar here. So hopefully you had a chance to try this out or think about it. And now we're going to go over it. So in this case, the favorable outcome here is going to be drawing 1 penny. All right, and we know the favorable outcome is just 1 penny because there's only 1 penny in the jar here. All right, so let me just write a P here. So P is for probability. So the probability of drawing a penny is going to be 1 divided by what? Well, it's the favorable outcomes divided by the possible outcomes. So how many possible outcomes are there if I go to draw 1 coin from this jar? Well, there's 1, 2, 3, 4 coins here. All right, so written as a fraction, the probability of drawing a penny from this jar is 1 over 4. Now, we can also write this as a decimal, and you can do that in two ways. So you could just do 1 divided by 4 in your calculator. That's going to give you 0.25. Or you could just memorize that 1 over 4 is equal to 0.25. Or we could also write this as a percent. And the way that you can do this is you just take the decimal and you move it to the right 2 places, and then you're going to replace it with a percent sign. So that would just simply be 25%. And lastly, we could also write this as a ratio, and that's actually sounds a little more complicated than it is, but to write this as a ratio, we would just say 1 out of 4. All right, so the probability here is 1 out of 4, and again, we can write that as a fraction, as a decimal, or as a percent. So this brings us to an important point, and the point is that probabilities can be written in multiple forms on your test. And these forms include fractions, decimals, percents, and ratios. So for fractions, one thing to remember is that the answer choices are almost always going to be written in simplest form. But you'll also may encounter probabilities as decimals, and really there's some values like 1 over 4 that you should memorize that's equal to 0.25. For example, 1 over 2, that's just equal to 0.5. But if you don't have all these values memorized, then you can just do it in your calculator. And you do that by you take the top number in the fraction and you divide it by the bottom number. So if it's 1 over 4, you just hit 1 divided by 4 in your calculator, and that's going to convert it to the decimal form. And then once you have it in the decimal form, you can pretty easily put it into percent. All you do is, again, you can do it in your calculator, or you can just take that decimal point, you want to move the decimal point to the right 2 places, then replace it with a percent sign as I just showed in that example. And then ratios, that's just like saying 1 out of 4 or something like that. So I just want you to be mindful of this because I want you to get in the habit of looking at the answer choices, just take a quick glance at them whenever you have a multiple choice probability problem to see how the answers are written. So for example, if all the answers are written in fraction form, you don't need to calculate your answer as a percent or as a decimal. That's just going to waste your time. Okay, here's another example here, and if you got that last question wrong or didn't fully understand it, now's your chance for redemption, and if you got that last question right, now's your chance to go 2 for 2. So the question is, if I put a penny and a quarter in a jar, what's the probability that I'll randomly draw the quarter out? So go ahead, pause the video, and try to figure this out. I want you to calculate the simple probability of drawing that quarter out. Okay, so we know here, and we're going to go over this example a little bit faster because it's similar to what we just did, but I really want to drive this home because on your test it's not going to get too much harder than this, right? So the number of favorable outcomes here in this case is just 1, because we know that there's only 1 quarter here. So let P equal probability, and the favorable outcome here would be drawing the quarter. There's only 1 quarter, so we'd say that that's 1. The possible outcomes here, well, we know that that's going to be 2 because there are 2 coins in the jar here. Okay, so as a fraction, the probability is 1 over 2. All right, and as a decimal, it's 0.5. And again, if you didn't know off the top of your head that 1 over 2 is 0.5, all you do is you take 1 and you divide it by 2 in your calculator, and it's going to give you 0.5, right? And so to write this as a percent, you just take this decimal, you move it to the right twice, and then you replace it with a percent sign. So we would say that that is 50%. Let me squeeze the percent sign down here. 50%, and again, to write it as a ratio, we would just say it's 1 out of 2. So now let's switch gears to experimental probability. And this is probability that's calculated based on what happens in the trials of an experiment. And there's a formula for this too, and the formula is experimental probability is equal to the favorable outcomes, or favorable outcome, divided by the trials in the experiment. So the number of favorable outcomes divided by the number of trials in an experiment. And we'll look at an example of this too. So here's an example now for the experimental probability. And in this case, what I want you to do is suppose that I take a penny and I flip that penny 10 times. and I get the following results, which I have written down for you right here. On the first flip I get heads, second flip I get heads, third flip I get tails, then I get tails, heads, tails, tails, heads, heads, heads. So I want you to tell me, what is the experimental probability of getting tails? And I have the formula up here where we have experimental probability, again, it's equal to the favorable outcomes divided by the trials in the experiment. And here, flipping the coin, that's our little experiment. So go ahead, pause the video. I'd like you to give this a try, and whether you get it or not doesn't matter, but we're going to go over it and we'll learn how to do it. So let's talk about this question right now. And so let me just write P here for experimental probability. And I don't want to waste the time by writing experimental probability out, so I'm just going to say P. And we know that this is going to be equal to the number of favorable outcomes. And in this case, is asking us about the experimental probability of getting tails. So we look at the results here and we want to count the number of times that I got tails in this little make-believe experiment. So 1, 2, 3, 4. 4 times. So in this case, the favorable outcomes are going to be 4. And the number of trials in the experiment, well, we know that I flipped the coin 10 times, so that tells you right there that it's 10. Or you can just count them. You could go 1, 2, 3, 4, go all the way up, count all the different trials here, and you could also see that there were 10 results here. All right, so we see that the probability of getting tails is 4 over 10 written as a fraction. But this fraction isn't in simplest form. So the way that we can do this is, because 4 is an even number and 10 is an even number, we can divide 4 by 2, we can divide 10 by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. So written as a fraction, 4 over 10 in simplest form is equal to 2 over 5, or 2/5. So that would be written as a fraction in simplest form. Now we could write it as a decimal, and 2/5 as a decimal is equal to 0.4. And you could do that in a calculator. And now to get that as a percent, we would just take this decimal, move it to the right by 2 places, and change it into a percent sign. So we would say that that's 40%. All right, so that's a little experimental probability question for you. Another really important kind of probability that you might have to calculate on the test is called independent probability. Now, when one event does not affect the probability of another event, we say that these events are independent. And the trick is that you can multiply the probabilities of each event occurring to get the probability of both events. And this might sound kind of like a mouthful, so let's unravel it by looking at an example here, and this should be a lot clearer to you. So the question says, suppose Jane flips a penny and Jackson flips a quarter. What is the probability that both will land on tails? So pause the video, try to figure this out, and then we'll go over it. Okay, so let's go over this question now. And so if Jane's going to flip a penny and Jackson's going to flip a quarter, both of these events are independent of each other. So the probability of that penny landing on tails is independent of the probability of the quarter landing on tails. So what this means is that we can multiply them. So first, let's just think about that penny here. So P equals penny in this case. So what's the probability of the penny landing on tails? So the favorable outcome in this case would be 1, right? Because a penny has 2 sides. It's got a heads and a tails. The favorable outcome is tails, so that's why we have a 1 here. And so the favorable outcome is 1. Total number of outcomes, that's going to be 2, right? Because again, the penny has 2 options. It could land on heads or tails. So expressed as a fraction, the probability that that penny lands on tails is 1 over 2. Now let's think about the quarter. So it's going to be the same thing here, right? Because a quarter, well, the total number of outcomes if you flip a quarter, it could be either heads or tails. So that's 2 possible outcomes. And the outcome that lands on tails is going to be 1. Because again, there's only 1 chance that it can be tails. All right, so the probability of that penny landing on tails is 1 out of 2. The quarter is also 1 out of 2. All right, so now since these are independent of each other, we can multiply them together. So I'm going to work in fractions here, but what you could do, you could convert these both to decimals, multiply the decimals. Doesn't really matter, but let's just stick to fractions here for right now. So we've got 1 over 2 times 1 over 2. So again, you could put this in your calculator, but the way to do this without a calculator is you multiply the top numbers of the fraction. So 1 times 1 is just 1. Then you multiply the bottom numbers in the fraction. So 2 times 2 is 4. And expressed as a fraction, the probability is going to be 1 over 4. And then there's also dependent probability. And in dependent probability, this occurs when one event occurs and the probability of a second event is altered by that first event occurring. And for dependent probability cases, you can still multiply the probabilities of both of the events. Just keep in mind that after that first event occurs, it alters the probability of that second event. And again, all these definitions can seem kind of abstract, so if you're scratching your head, don't worry. Let's look at an example to really drive this point home. Suppose Janice puts a penny, nickel, dime, and 2 quarters into a jar. And if she draws 2 coins, what is the probability that both will be quarters? And I'd like you to assume that she draws a quarter on her first draw. So pause the video, think about this, try to figure it out, and then we'll go over it. Okay, so let's go over this, and this is a little bit trickier than the other problems in this video, so if you had some trouble with this, don't worry, we'll get into it right now. So in this case here, what I want you to do is, let's just think about her first draw here. So for the first draw, what would be the probability that she pulls a quarter out of the draw on the first draw? So let me put this P for probability here again. And so the probability that she draws a quarter is going to be the number of quarters in the jar divided by the total number of coins in the jar. So in this case here, we've got a penny, that's 1, a nickel, that's 2, a dime, that's 3, and now we've got 2 quarters here, right? So we've got 1, 2, 3, 4, 5. So there's 5 coins in the jar. Okay. And how many quarters? Well, we know that there's 2 quarters. So on her first draw, the probability of drawing a quarter is 2 out of 5. All right. So now let's say that she draws that quarter, and now let's think about on her second draw. So let me write the second draw down here. So the probability of drawing a quarter on the second draw, assuming that she picked a quarter on the first draw, is what? Well, let's start by thinking about how many coins are going to be left in the jar. So if she already drew a quarter on the first try, there's still going to be a penny, there's still going to be a nickel, and there's still going to be a dime. So we have 3 coins right here. And then remember, if there were 2 quarters and she takes out 1 quarter, that's going to leave 1 quarter left in the jar. So there's going to be 4 coins total that are left in the jar. So the number of possible outcomes for her second draw is going to be 4. And like we just said, there's going to be 1 quarter left in the draw. So 1 quarter left in the jar, I should say. So on her second draw, that 1 quarter represents the one favorable outcome. So again, on her first draw, the probability of getting a quarter is 2 out of 5. And then once that quarter is removed, there's only going to be 4 coins left in the jar, and there's 1 quarter left, so that's why on her second draw, the probability of pulling that quarter out is going to be 1 over 4. If you followed that, then great work, and if not, then I'd like you to rewind the video, make sure that you can follow this, because the last step of the problem is that we're going to take these 2 probabilities and multiply them together, and that's pretty much the easy part, is multiplying these 2 probabilities together. But the harder part is making sure you understand how I got these 2 probabilities. So please make sure that if you didn't catch it, you rewind the video a little bit and rewatch this segment so that you understand how I did this, because this can be a little tricky for some people. But basically, you can put this in your calculator again, or you can just multiply right across here. So 2 times 1 is 2, and 5 times 4 is 20. And this fraction here is not in simplest form. Right, so we've got a 2 up top and a 20 down on the bottom, so let's divide both the top number and the bottom number by 2. 2 divided by 2 equals 1, and 20 divided by 2 equals 10. Okay, so if you think you're understanding how to solve these probability questions, then this is going to be a good way to test yourself, because now I'd like to go over some little bit harder examples of probability questions, and these are going to be more similar to the difficulty of what you can expect on the real GED test. So if you find you can understand these questions, then I'd say that you should be in pretty good shape for the GED test as far as probability questions go. And for these, I'm not going to tell you ahead of time if it's an independent probability or dependent or simple or whatever. I'd like you to figure that out as we go along here. So the first question here says, Andrew has a spinner that has 6 equal sections. One section is blue, one is yellow, 2 are red, and 2 are black. If Andrew spins the spinner one time, then lets Jane spin the spinner one time, what is the probability that both spins will be yellow? And please express your answer as a fraction. So go ahead, pause the video, try this out, and then we'll go over it. Okay, so let's go over how to do this question. So the first thing that I want you to think about here is what kind of probability question is this? And if Andrew spins the spinner and then Jane spins the spinner, the probability of Andrew getting a yellow, that's not going to have any bearing on the probability of Jane getting a yellow. So this isn't like a problem where if you draw one coin out of the jar, there's going to be one less coin for the second draw. No, it's nothing like that. It's just a straight up question where Andrew's spin doesn't affect Jane's spin. So this is an independent probability question. So let's think about it this way. So on Andrew's spin, so I'm going to put an A here for Andrew. So on Andrew's spin, what's the probability that he's going to get a yellow? So let's think. So the favorable outcome would be getting a yellow. So let's think, how many chances are there to get a yellow? Well, it tells us here that one section of the spinner is blue and one is yellow. So that means that there's one chance to get a yellow. So in other words, there's one favorable outcome. Now, what about the total outcomes here? Well, we're told that there are 6 equal sections, right? We've got one that's blue, one that's yellow, 2 that are red, and 2 that are black. So there are 6 equal sections. All right, so the probability written as a fraction would be 1/6 chance of getting a yellow. All right, the probability of him getting the yellow is 1 out of 6. And for Jane, it's going to be the same thing, right? So again, for Jane, what's the probability that Jane gets yellow? Well, there's one chance to get a yellow because there's one yellow space on the spinner, and there are 6 equal sections of the spinner. So again, the probability that Jane gets a yellow is 1/6. And now what we're going to do is we're going to multiply these probabilities together. And so we do 1/6 times 1/6. And again, to do this without a calculator, you just take the top number. So you do 1 times 1, which is just 1. 6 times 6 is 36. So written as a fraction, the probability that both spins will be yellow is 1/36. Okay, so now your example is Dan has 44 marbles in a jar. If 22 of them are red, 10 are blue, and 12 are green, what is the probability that Dan will draw a green marble on his first try and a blue marble on his second try? Now I want you to assume that on the first try, Dan does draw the green marble and that he doesn't replace it. So I want you to try to solve this question and then express your answer as a fraction. So pause the video, try this out, and then we'll go over it. Okay, so in this case, first let's calculate what's the probability that on his first try, Dan draws that green marble. So let's think about here first. So the probability of drawing a green marble, so I'll put a P here for probability, and I'll put a little green here for the green marble. All right, so how many total outcomes are there first of all? Well, we know that there's 44 marbles in the jar initially, right? So the total number of possible outcomes, in other words, the total number of marbles that he could draw is 44, right? And the total number of favorable outcomes here is going to be 12 because there are 12 green marbles. So to calculate the probability of drawing a green marble on his first try, we know that we would do 12 divided by 44. Okay, so let's put this in simplest form. And again, you can do that in your calculator, or you could do the simple way to do it. Let's see, we could just divide both numbers by 2. So what's 12 divided by 2? That gives us 6. What's 44 divided by 2 gives us 22. And you might say, well, we could do that same thing again. What's 6 divided by 2? 6 divided by 2 is 3, and 22 divided by 2 is 11. So whenever you have even numbers, you can just keep dividing by 2 until you can't anymore, and then you're going to be in simplest form. Right, so that's what we did here. So the probability of Dan drawing a green on his first try in simplest form expressed as a fraction is 3 out of 11. So now let's talk about a second draw. So that green marble is gone. So assume that he does get that green marble. He takes it out of the jar. How many marbles would then be left? Well, that's going to leave us with 43 marbles left now, right? Because on his first draw, say that he draws that green marble, takes it out, doesn't put it back in. We're going to have 43 marbles left, and that's true, right? Because there's not going to be 12 green anymore. There's only going to be 11 green left. So now we want to know what's the probability that he draws a blue marble on a second try. So the probability of him drawing a blue marble is going to be equal to the total number of favorable outcomes divided by the total number of possible outcomes. So the possible outcomes this time is going to only be 43 because, again, there were 44 marbles initially, but he pulled one out, so there's only 43 left. But the number of blue marbles in the jar is going to be exactly the same as it was before because, remember, we're supposed to assume here that he actually drew that green marble on the first try. So the number of blue marbles stays exactly the same. So the number of favorable outcomes is going to be 10 because there are 10 blue marbles. All right. So we've got 10 out of 43, and in this case, this is kind of a strange number, but this is going to be the simplest form. So we've got two kind of weird numbers here. We've got 3 over 11, and we've got 10 over 43. So let's multiply these together, and we're going to get a strange number here, but that's okay because numbers on the real thing don't always work out perfectly. All right, so 3 times 10 is going to give us 30. Here, let's use a calculator. 11 over 43 is going to give us 473. All right, 473. And so this is in simplest form. So if you found this video helpful, then please check out my other math videos on this channel. And good luck on the GED test. I really hope this video was helpful for you.